In example 7.1, you're being asked to state the domain and the range, and a quick reminder, domain is referring to any x or horizontal values that are possible, and the range is any possible y values. So having a look at our first example here, you can see that we've got horizontal asymptotes at -3 and 2, and so that tells us that our domain is the set of all x such that x does not equal -3 or 2. Oops, wrong bracket. If you wanted to write that using interval notation, it would be x is an element of -∞ to -3, neither of which are included, or -3 to 2, again, neither of which are included, or 2 to +∞. Again, another reason why I like set notation better, because it's a little bit clearer. The horizontal asymptote is the y-axis, so the range is going to be range is equal to the set of all y such that y does not equal 0. Or again, using interval notation, y is an element in the set from -∞ to 0, not included, or 0 to infinity, and neither is included. Either one is fine. All right, having a look at example B, we've got a piece of a function here. So first of all, having a look at our domain, which are our x values. Our lowest x value is this one here, which is -1, and our highest x value is this one here, which is 5. So our domain is the set of all x such that -1 is less than or equal to x. It gets the equal because it has the solid dot, or x is less than 5. And the 5 is just less than, not less than or equal to, because it's got that open dot. That point is not actually included. Or you could say x is an element of, now -1 is included, so it gets the square bracket, whereas 5 is not included, so it gets the curved bracket. You don't need to do both forms of notation, I'm just showing you how they work. All right, our range is going to be the set, the set of all y such that, now if we're looking at our range, our lowest y value is 0 and our highest y value is 28. 0 is included, whereas 28 is not. So y is going to be between 0 and 28, where 0 is included, 28 is not. Or our range is y is an element of 0 is included, 28 is not. All right, on this next example, if it's not immediately obvious to you by looking at the actual function, the very best place to start is to draw a graph. And I've actually done these graphs in f of x further down the page. All right, now without any specification that we're talking about plus or minus the square root of 5, we are only talking about positive square root 5. And when we're talking about domain, you've got to have a think about which values of x make sense in this context. We know that we can't take the square root of a negative number, so therefore this x minus 5, which is under our square root sign, that has to be greater than or equal to 0. So x minus 5 has to be greater than or equal to 0, which means x has to be greater than or equal to 5. If x is less than 5, for example 4, we would have the square root of 4 minus 5, which is the square root of -1, which is imaginary and doesn't belong on the Cartesian plane. So our domain is restricted to values that are greater than 5. So writing it in proper notation, domain is the set of all x such that x is greater than or equal to 5. Or x is an element of, now 5 is included, so it gets a square bracket, all the way through to positive infinity, which is not included. The range, there's no value of x that we can take a square root of and end up with a negative value of the function anywhere down here. So our range is limited to values of y. So a set of all y such that y is greater than or equal to 0. Notice that y can be 0 because if x is 5, we have y equals the square root of 5 minus 5, which is the square root of 0, which is 0. So y can be 0, but it can't be a negative number. And I'll do the next 3 examples in the next videos.